Hello, my dear students. Welcome back to my YouTube channel. So, today we will be starting lecture number 5. So, in this particular lecture, we will be starting superposition principle or forces between multiple charges. Then we will be discussing regarding equilibrium problems and then SHM problems. Okay. Hello, beta. Hello, Subara. Hello, Hasana. Hello, Miss Beta. Great, right? So you will be having some today we will be discussing some numericals from GPYQs from HC Verma, from Irodo, right? So we will be discussing some very great problems from these books and which are very relevant to your examinations. Okay, so you need to be in the lecture. So you will get some sort of confusion during the numericals. So you need to ask me those doubts. Okay, Shreya, right? Hello, Shreya, beta. So we will have here a new student, Imran Khan. Hello, beta. So let's start today's session now. Okay. Okay. So in previous sessions, we had the discussion on charges, right? We had the discussion on charges, properties of charges, charge densities, methods of charging. Then we had a discussion on Coulomb's law. Then the different types of permittivity. Then I guess we had the discussion on what vector form. Yeah, I know you, not sure, but I know you. So, in today's session, we will be discussing superposition principle first. Okay, I think I am just visible and audible, right? One second. One second. One second, beta. Give me 1 second. Sinan, hello, beta. Hello, Arushi. See? Okay. So, in today's session, you will find some amazing numericals for your NEET, right? Okay. So, now let's start today's session with superposition principle. We will start with what? Superposition principle. Superposition principle. Superposition principle. Okay. So, what is superposition principle? Superposition principle means if we have a point charge, if we have a here, let us suppose we have a point charge here, this one, this Q naught, it is a point charge. Okay. Now, around this point charge, we have lot different point charges. Now, what will happen? Here we have Q1 now. So what will happen with this Q1? Q1 will apply some force on Q naught. So this will represent force on 0 due to 1. And I will just put it a vector. Okay. Now, in the same way, the Q2 will apply a force on Q naught. It will apply force like this. It is a force on 0 due to 2. And the Q3 will apply the force on Q naught. It will be like this. It is force on 0 due to 3. In the same way, the 4 will apply a force on Q naught like this. It is what? A force on 0 due to 4. In the same way, let's say we have n particles, right? So this n particles will also act here, no? So it will apply a force like this, force on 0 due to n. So look, on a single particular body, that is q naught, we have multiple forces. On a single particle q naught, we have multiple forces. We have a multiple forces. So how to get the net resultant force on q naught? How to get the net resultant force on q naught? Simply we have to vector add all these forces. So I will write force on net force. It will be equals to force on 0 due to 1, force on 0 due to 2, then we have force on 0 due to 4 due to 3, and so on up to force on 0 due to n. Okay, this particular relation is known as superposition principle. This particular relation is known as superposition principle. That means net force on any body is equals to the vector sum of all the forces which are acting on the particular body. Okay, so this statement is known as superposition principle. So this is a derivation. I am just showing the derivation part. Okay, then we will switch to the magnitude only and the numerical perspective only. Look how we can get it. Look, so I will write, look, what is force on 0 due to 1? What is F now? Look, I can write F on 1 due to 2. In the previous class, we discussed it. It was equals to, sir, K, Q1, Q2 whole divided by, it is R square, then R vector, it's to 1. So if I need to just open it, so I can write it as a K, Q1, Q2, then it is R to 1 vector whole divided by R cube. Whole divided by R cube, or you can write R to 1 also. There is no issue. Okay. So I guess this, but these things, these things we discussed in the last class of what? Vector form of Coulomb's law. Now you can see here, now we have F01. So I can write K, Q0 or Q naught, Q1 whole divided by, I can write here what, beta? I can write here, sir, it is R 2 1. I can write it as R10 cube. Then here I can write R10 vector plus, what is F02? I can write K, Q0, Q2 whole divided by R20 cube, then R20 vector plus up to so on. What is the last term? So we have, sir, it is K, Q0, Qn. I got stuck 1 second. Okay, so I can write whole divided by R n0 cube R n0 vector. So I guess I can take some quantities common. I can take K, Q naught common. Okay, then what I can write here? So I can write here Q1 divided by R1 naught or R10 cube, then R10 vector plus I can write here Q2 whole divided by R20 cube, then we have R20 vector plus so on. Then what we have? We have Qn only whole divided by Rn0 Q, then Rn0 vector. Look now. So in a very shortcut way, how I will represent it, F net, it would be equals to, look, K Q not common, then summation of I from 1 to n, then Qi whole divided by Ri0 cube, then Ri0 vector. This is how we can represent this one in a very shortcut way. What this summation is, what this symbol represent, it is sum. Okay, that means firstly we have to put I1, then plus, we have to put I2, then plus I3 up to what? So up to n. So initially we have to start with 1 and we need to end at n. So this one is a derivation of superposition principle. How we can get it? Okay, if you are preparing for your board examinations, you can just copy this one. Okay, you can take a screenshot for this one and you can write this one. Derivation of superposition principle. This one is easy, no? One second, I guess there is some network issue also. I need to just check it now. The network is fine. Okay, now. So if you have any doubt regarding this particular slide, you can just ask me now. Okay, if not, then we can just switch to a different part. Okay, I guess you don't have any particular issue with this particular one, so we can just next part. Okay, so look, this is how we will represent it now. This is how we will represent it. But how to find f net? This is a representation in a vector form. But basically, in a numerical, we don't need to write this much thing. Okay, it is only for your derivational thing. Now, it is not important for your numerical perspective. So for numerical thing, how we need to manipulate it? Okay, so back in our 11th standard, if you have noticed it, one thing, how to find the resultant of a vector. If this is my A vector, this is my B vector. So I will write, this would be my C vector or my resultant vector. Okay, this is my alpha here. I guess you know something like this, no? This would be my theta here, 90 here. This would be my B, it would be B cos theta. And this side is B sin theta. So my resultant would be equals to, it is mod, sir, it will be A square plus B square plus twice AB cos theta. I guess you have the memory very good, no? From your 11th standard. We can write the resultant of a vector in this particular way. Okay. And if we want to find this alpha, so what we can write? It is tan alpha. It was equals to B sin theta whole divided by A plus B cos theta. This thing we use it to just complete in our 11th standard. Okay. This is just for our recap position. Okay. So then we had a special case. Then we had a special case. Special case is better when my vector A mod is equals to vector B mod. Okay. When my vector A mod, that means magnitude of A vector is equals to magnitude of B vector. Both are equal to, let us suppose, A. So the shortcut way to find the net, is, it is 2A cos theta by 2. Just remember this thing, right? if you are adding two vectors, just remember these things, right? If you are adding two vectors, if the magnitude is different, so you can use this formula. But if the magnitude of two vectors that you are adding are same, you will use this formula for a shortcut purpose. Okay, easy now. One more thing, that if here my theta is 0 degree, or if my theta is 180 degree, third, if my theta is 90 degree, so what will be my r? It will be for 0, cos 0 is 1, it will become a square plus b square plus twice ab. So I can write here, sir, it will be a plus b. If my theta is 180, so cos 180 is minus 1, so I can write it what? A minus b. If my theta is 90, cos 90 is 0, I can write a square plus b square root. Okay, you will find the detailed video of this particular slide from my one shot series vectors. हाँ बेटा, कौन से वाले पार्ट को हिंदी में बोलना है, कौन से वाले पार्ट को? One shot series vector. Okay, I guess you are not now in the lecture, so I guess we need to just okay. So this, look, if you want to get your numericals done now, you need to be very good in what? In basic maths, in vectors. Yes, beta, I am on the Telegram also. Okay, and you will find my Telegram group link na in the description part. You can write Shakoor sir physics. You will get my Telegram link ID. Okay, and you will get the notes of these classes also for your board examinations. Okay, I guess now everything is clear, crystal clear up to this particular point. Now let us put these things into numericals. How we can get it? Now, first in numerical on the screen, and it is this numerical is a good one, right? So we have three. Look, so based on the superposition principle, we can do this numerical. This numerical is like three equal charges. What we have, beta? We have three. So we have three equal charges. So we have three equal charges. That means we have Q1 charge, it is equals to Q2 charge, it is equals to Q3 charge, and the value of all these three is equals to Q. Okay, are held fixed at the three corners of an equilateral triangle. So what we have? Sir, we have an equilateral triangle. So this is my equilateral triangle. This is me what? This is my equilateral triangle. Do you know what is equilateral triangle? Do you have any idea about it? Do you have any idea about equilateral triangle? Okay. So basically, equilateral triangle is a type of triangle in which each and every angle is equal to 60 degree. Okay. That means, sir, this angle is 60 degree. This one is also a 60 degree. This one is also a 60 degree. Okay. Now we have three charges. Q is here. So it would be plus Q always. It is Q and Q. Okay. Now the second, the sides are given to be A, and A. Okay, done. Find Coulomb's force experienced by any of the charges due to rest. It is saying that, let's suppose we will take this one. So we have to find out what will be the net force on this one. Net force. If we need to find net force, so we have to use superposition principle. Na? How we can get it? Look, we know that this positive will repel this positive, so it will be along the line joining 2 points. So it would be, sir, K Q1 Q2 divided by A square. Q1 and Q2 are same. I can write K Q square divided by A square. This one. In the same way, this one is positive, so it will just repel this one also. Okay. So the answer would be K Q1 Q2 whole divided by A square. So can I write Q1 Q2 same? Now I can write K Q square by A square equal. Yes, sir. If this is 60, so this would be also 60 now. Okay. Look, magnitude same. Here what you can see now, look, magnitude of these forces are same. This one and this one. Okay. Magnitude of this force and this force is same. If the magnitude of two forces are same and we have to find the net force of these two forces, how we can get it, sir? We know one formula. Which one better? Sir, can I use a formula here? Which one? I guess I can use F net. F net is equals to 2A. In the place of A, I can write F 2A cos theta by 2. Yes, sir. Shortcut way. 2 is 2. What is F? Sir, F is K Q square by A square. Cos theta. Sir, theta is 60 degrees. So cos theta by 2. Now it would be equals to 2K Q square divided by A square. I have cos theta now. Okay. So can I write here 2Q square by A square? Cos theta 30 is how much? Under root 3 by 2. 2 cancel out. So my answer came out to be under root 3 KQ square by A square. So this will be my answer of this particular numerical. Easy? Easy, no? This is how we have to manipulate the numericals. This is how we need to proceed in our numericals. We don't have that much of time now that we can just do one step, then one step. Now we have to just think about now which formula I need to put here, and is there any shortcut that I can use? Yes, if yes, then you can use it. Now, second question. So in this, we have the same question now. Look, we have a equilateral triangle. That means all angles 60 degree, all sides equal x. So we have to find the charge. We have to find the force on this particular charge. Look, this one is Q, this one is plus Q. Both are plus Q, so my force will be like this. Sir, my force F, let's suppose it is F1. Is it equals to K Q1 Q2 by x square? Look, K is K, Q1, Q2 are same. I will write Q square by x square. Correct? Now this one is negative, this one is positive. Positive, negative attract. So it would be like this. It is F2. Is it equals to K? Same Q square by x square? Yes, sir. Look, both values are same. Both values are same. So which formula I need to use here? Sir, I will use F net. F net is equals to, sir, what? It is 2F cos theta by 2. Okay. Sir, is it 2F? What is F? F is K Q square by x square. Cos. But what is theta? Theta is the angle between these two forces. That means this particular angle. Look, this one is 60 degree. This one is 60. This one is 60. But whole angle is 180. Now look, the whole angle is 180 degree. And if this angle is 60 degree, I guess this would be how much? Is it 120 degree? Yes, so this angle would be 120 degree. So I will write here, sir, it is cos 120 degree by 2. By further simplification, I can write 2 kq square by x square, then we have cos 60 degree. And cos 60 degree, look, I can write here F net is equals to 2kq square by x square. Cos 60 is how much? It is, sir, 1 by 2. Cancel out. So therefore, my net force on this plus q would be kq square by x square. This one is my answer for this particular question. Okay, easy enough. This is how you have to manage your numericals. Very shortcut way. Okay. Next question. Find net force on charge minus q. So where is minus q? Sir, this one is minus q. So we have to find net charge on this, sorry, net force on this one. So look, this one is negative, this one is positive. So positive negative attracts. So we will be having one force here. This force F1, is it equals to K? Q1 is Q, Q2 is 16Q divided by R square. R square is 4x square. Can I write it like, sir, 16K Q square divided by 16x square? 16 cancel out. My answer is K Q square by x square. Okay, for this one. In the same way, negative positive attracts. So I can use, sir, let us suppose it is F2. So now, what is F2? Sir, F2 will be equals to K. Q1 is how much? Q. Q2 is 9Q whole divided by x square. X is how much? 3x square. So I can write here 9KQ square whole divided by 9x square. 9 cancel out. My answer would be, sir, K Q square by x square. So here you can see now both the magnitude of the forces are same and the angle between these two vectors 90 degree. So what will be my F net? Sir, F net would be 2F cos 90 by 2. I can write 2F is equals to K Q square by x square. Then we have cos 45 degree. So I can write here 2kq square by x square cos 45 is how much? 1 by root 2. So look, 2 divided by root 2 equals to root 2. I can write it is root 2 times kq square divided by x square. Clear? Easy, no? This is how we can do it. And this one is a JEEPYQ, okay? If you are thinking now these numericals are some sort of bit twisted, no? Yeah, these are from JEEPYQs. Okay, now next numerical. Yes. So we have next numerical. Now we got a four-sided figure. We have to find a force on this particular one. Okay, how we can get it? Look, this Q will applying force F, let us suppose F1. It is equal to K Q1 Q2 by length is L square. Look, Q1 is Q, Q2 is Q. I will write it as a K Q square by L square. Okay. In the same way, this will apply a force on this Q. It will be acting a force like this. F2, it would be equals to K Q1 Q2 by L square. Q1 Q2 same, so I will write K Q square by L square. Forget about this one. For a particular time being, forget about this one now. So if we have two forces, look, this is a square with angle 90 degree. So this will be also 90 degree, right? If two forces are acting on a particular particle and the magnitude of these forces are same, so yes, we will get it is net. We will get it is net like this now. It is net, F net. It is equal to 2F cos theta by 2. So what is answer here? F net. It will be 2F cos theta by 2. 2, what is F? F is equal to K Q square by L square. Then what we have? Cos 90 by 2. So is it equal to 2 K Q square by L square? Then we have cos 45. Cos 45, I can write 2K Q square by L square. Cos 45 is 1 by root 2. So my whole answer will be equal to how much? 1 second. So my whole answer will be equal to under root 2 K Q square by L square. Okay. So the effect of these two is equal to this one. And it is equal to under root 2 K Q square by L square. But look here, we have one more force. We have one more force. This force is also, this will also apply some force now. Look, this will also apply a force. Okay, let's say it is F3. It would be equal to K Q1 Q2 by X square. X is the distance between these two. Look, if this is my right angle triangle now, base is L, length is, sorry, perpendicular is L. So hypotenuse is equal to L square plus L square root. So is it equal to 2L square root? Is it L root 2? Is it L root 2? Yes, sir. Is it L root 2? Okay. That means I can write here. Look, 1 second. Okay. 1 second, 1 second. Yeah. So I can write here, sir, K is K, Q1 is Q. I can write Q square whole divided by, in the place of X square, I will write what? L root 2 square. So it is equal to K Q square divided by 2L square. Look, this force and this force both are in same direction, so we will add them, right? So I need to add this one, I need to add this one, and I need to add this one to get my resultant value. I need to add these two values. Okay, I need to add these two values to get my answer. Look beta, how we can get it? So the net, at the end my net value will be equals to, it is K, 1 second, it is hang. Okay, 1 second. Okay, 1 second. Okay, it is equals to K Q square by 2L square plus root 2K Q square by L square. So now what I can do here now, look, I will take K Q square by L square common. Then internally what we have 1 by 2 plus root 2. So this one is my answer to this particular small numerical. This is how we can get the answer. Easy. And you can notes now, with the 1 numerical passing on, the level of difficulty is increased. No? You need to think like that. No? That yes, we had done one particular type of numericals. If positive are there, how we need to manipulate. If positive negatives are there in triangle. Now, if in square we are having this much of problem, how we need to tackle with it. No? Any problem up to this particular numerical? Do you have any problem with this particular numerical? Okay, I guess you don't have any problem, no? Okay, so let's do more difficult from this one. Okay, this is a figure, no? And this numerical, this was a PYQ in your JE and your in your NEET also. Okay, this one is a very good one. So numerical is find the x component. We know that if there is any force between x and y axis, so that particular force will have two components, one in x and one in y. So in this particular figure, we have to only calculate the forces on Q1, but only in the X component. Okay. How we can do it now? Look, this is minus Q. This one is also minus. Minus means repulsion. So it is force will be like this. It would be K Q1 Q3 whole divided by A square. If this one is theta, though, this one is will be also theta. So if we have two components now, one component is this one. So the component with theta is known as cos theta. So I can write it as K Q1 Q3 by A square, then what? Cos theta. One component will be here in x axis, x axis and y axis. So I will write it as K Q1 Q3 by A square, then sine theta. But we have one more force here. Look, we have one more force here. Look, this plus Q will attract this minus Q in this particular way. Okay, so the value would be K Q1 Q2 by distance is B, so B square. So the net force in x axis will be equals to this one plus this one. So I can write here, sorry, K Q1 Q2 by B square plus K Q1 Q3 divided by A square sine theta. This one represents my answer. If you have any doubt regarding this particular slide, you can ask me. There is no issue. Yeah, is my handwriting visible to you? Let me check. Let me check. Yes, it is very clear now. I'm good with the handwriting part, okay? Okay, next numerical. Next numerical is like if we have a regular polygons. Regular polygon means if we have the sides equal, no? If we had the equal sides, then how we can do our numericals? Am I audible? Yes. So look now, if we have a what? If we have a regular polygon, here, look, we have a pentagon here, no? Pentagon, we have a triangle, square. These are a regular one, okay? And at their sides, no, or at the points or the vertex, we have one charge. So what will happen? Look, you can look now. I will just zoom it, no? For the better understanding, I will zoom it. Look, I will zoom it. This one I will zoom it, okay? This particular figure I will zoom it. Look. What will happen here, no? This one is positive, this one is negative. This one is positive, this one is negative. Positive, negative attract. So it would be like this. Okay. So if the distance is x, so this is my force 1. I guess I can write, sir, force 1 is equals to K, Q by x square. Positive, negative attracts this one. It is F2. Look, regular, same sort of distance, no beta? It is F2, K, Q, same x square. For this one, look, if this is F3, so I can write K q by x square. This one also x. Look here. X, x. This one is F4. So I can write k q by x square. Same x. This is F5 k q by x square. K by x square. Look now. We have the regular word here. Now, regular means the angles between these are equal. Angles between these are equal. So one property that we have learned in back in our studies in our 11th one, right? That is, if we have a regular body. If we have what? If we have a regular body. If we have a regular body. Done? And these are coplanar with each other. That means these are from only one plane. So if we have a n coplanar vectors with equal magnitude, look, magnitude equal separation. Yes, sir. So the net resultant force will be equals to 0. So what will be the force on the center one? It will be 0. In the same case here, sir, it will be 0. So if you need to find F net, sir, find net will be 0. In the same way, here it will be how much? 0. So in a regular polygon case, if you have to find the net force at the center, so always it will be how much? 0. Shunya. 0. Okay. This is a very important property here, no? You will find some PYQs based on this particular property. Look how? Look now. Yeah, these two particular figure represent regular polygons. Yes, these are regular polygons. Now you need to find the net force on the particle which is situated at the center. That means we have to find net force on this particular particle. How we can do it now? Let us suppose, beta, if I will be asking you what is plus q minus q, what is the answer of plus q minus q? Sir, it is 0. So instead of 0 coulomb, can I write plus q minus q? Yes, sir, we can write here now. Look, here we don't have any charge. So can I write it is plus q minus q? Yes, sir. So look, this plus q, this plus q, this plus q, this plus q, this plus q. Collectively, this is the same case of this one. Similar case of this one. So yes. So due to which the net force due to these positive charges will be 0. So now we have here only 1. We have this minus q. This will act as some force on this one. So distance is given to be a. Now simple numerical, if we have minus q, then we have minus q. So sir, what is the force between these two? Sir, I can write force is equals to k q divided by a square. Simplest way to get our answer done. Simplest way to get our question done, na? Simplest way. Okay. So now we just convert this big chunk of numerical into the small one. Okay. In the same way, look here. We have plus q, we have plus q, we have plus q, we have plus q. If somehow here we will get plus q, na, so we will get our answer done in a very good way. So instead of this minus q, how to split it? Can I write here, sir, it is q minus 2q? Yes, sir, look, q minus 2q is minus q, no? So yes, I will split this q into two parts. I will write it here, sir, it will be equals to plus q, then minus 2q. Look, this plus q, this plus q, this plus q, this plus q, this plus q. The net force due to these positive plus q will be 0. Now only what we have minus 2q. Then we have center q naught. Distance is a. So we will find simple F net. Sir, it is equal to k. Q1 is 2q. Q2 is q naught divided by a square. This is my answer, na? This one is my answer. Easy. Very easy, na beta? This is very easy. How we can manipulate our questions, right? How we can do our questions now? Very easy. If you have any sort of doubt na in the class, you can ask me here, na? There is no fun of just live classing, na? I will just record the lecture and just put here. You will also watch that thing also. But live means if you find any doubt, if you don't know this how this particular point came, now you can ask me there. Okay, now I don't think you will have any doubts now. So let us move to the next numerical. Okay. So next numerical, like we have a square. We have a square. Okay, on the opposite vertices we have same charge q, capital Q. On the rest two we have small q. If let us suppose on this particular charge, if my net q, if a net force on this one is 0, what is the ratio of q by q? Sir, how we can do it now? Simple way. Let us break down it into a numerical portion. No? Look, this q, let us suppose, will repel this q. So the force will be like this. Okay. So my force is equals to, sir, k q by x square. In the same way, this q will repel this q. Now it will be like this. Force 2 k q by x square. What is the net force between these two? Look, force is same, so net will be along this line, and we have the formula for net now. It would be 2f cos theta by 2. I will write 2. What is f? Sir, f is kq by x square. Now we have cos theta is how much? It is 90 by 2. It is 45. I can write 2 kq by x square, then it is cos 45. It is what? Cos 45. So can I write it equals to 2 kq whole divided by x square? Cos 45 is 1 by root 2. So my net answer is root 2 times kq by x square. Okay, that means now there is nothing to do with these two forces. Why? Because we calculate the net of these two. Now we have one more force. This one also applies some force on it, no? Repulsion. Yes, sir. It is F3. It is equals to kq. It is kq squared by this. Look, x. It would be root 2 times x by Pythagoras theorem. We had done this one. Huh? It is how much? Sir, root 2 times x square. It is equals to kq squared divided by 2x square. Now we have two forces. One force, this one, and one force, this one. According to question, the net force is 0. Look here. Now you can see here. Sir, net force is 0 on this one. So I can write here, sir, it will be equals to kq square divided by 2x square plus under root 2 times kq whole divided by x square. Net is 0. I can write like this now. Net is 0. Look, sir, k cancel out. One big q, one q cancel out. X square cancel out. I can write here, sir, it is 2 by q by 2 plus root 2 times q equals to 0. So I can write here, sir, root 2 times q is equals to minus q by 2. Or q came out to be minus q by 2 root 2. So what we need to, what I have to find now, it is q by q. No. I don't need to do this one now. Look. Answer is correct now. Look. I can write q by 2 equals to minus under root 2 times q. So q is equals to minus 2 root 2. So q by q came out to be minus 2 root 2. So yeah, this is my answer. This one is my answer. Okay, done. Be in the class now. We will do some good numericals. Okay, be in the class. Yes, I know that it is already 11:22. Today. We can just stretch class. Okay, next numerical. Okay, so we have now most. I can say the most important one. Why? Because you will learn new stuff, no, regarding to this pendulum case. If we are just managing this pendulum case, now you will find some amazing results from this particular one. Okay, look, if we have two identical pendulum, this is one pendulum, second pendulum. We have two simple, two identical. Identical means carrying each equal charge and equal masses. And both the particles, here we have one particle, here I have one more particle. These two particles are separated by r distance. By r distance. And the length of this insulating string is equal to L and L. Here it is theta 1 and theta 2. Look, how we can manage this thing. Look, this is plus, this is plus. Plus plus will repel. So this will have a repulsion like this. It will be equal to, sir, K Q square by R square. Look, it is having mass, so the weight would be mg downwards. So look, this is string, this will be have some tension T. Theta, so these will be the same theta now, because same charge to same theta, same mass. So if this is theta, this will be also theta. This is T, it will be T cos theta. And this will be how much? T sin theta. So can I write here, sir, T sin theta is equals to kq square by r square, and T cos theta is equals to how much? M into G. Now let us divide these two. Look, T cancel out. I am getting sin theta by cos theta is tan theta. So tan theta is equals to kq square divided by r square mg. R square mg. So from this particular slide, you came to know one thing, that tan theta is inversely proportional to the mass. Tan theta is inversely proportional to the mass. What does it mean? Suppose we have one condition here. Initially, this is Q, mass is M. This is 4Q, mass is M. Look, theta. Both will be same theta. Do you know why? Because you will be having same force. If this one is applying some, let us suppose 2 Newton force here, this will also applying some 2 Newton force here. Why? Action and reaction pair by Coulomb's law. Okay, now let us suppose, look now, this condition. If this is M, this is 4M. Charge might be same, there's no issue. Look, this one is heavier, this one is lighter. So this will have Q1, this will have Q2. And Q1 will be less than Q2. Why? Because heavier displaces less. More mass, less displacement. I am right-handed. This is sort of the inversion of image, right? So look, more heavier, more less displacement. You need to just remember this thing now. Look, more weight, less displacement. Less mass, more displacement. Okay, just remember this thing from this particular slide. The displacement, now the theta doesn't depend on Q. Now why? Because Q follows the action reaction pair. No, There is no issue with the theta. Sorry, this charge Q. The only thing is mass. Mass is inversely proportional to what? Mass is inversely proportional to your theta. Done? Okay, look now. If you have to calculate tension T, if you need to calculate tension T only, what you can do now? Either you will use this equation or this one. Either you can use the upper one or you can use the lower one. We can do one thing. Let's look now. Look what we can do. Look. We know that, sir, T sine theta is equals to my electrostatic force. I will write it Fe, no? Not K Q1 Q2 by R square. Simple way. Now, what is T cos theta? What is T cos theta? So, T cos theta is equals to mg. T cos theta is mg. Now, let us square the whole term. So, can I write here that it is T square sine square theta equals to Fe square? Then, T square cos square theta is equals to mg whole square. First equation, then second equation. Now add first and second. I will write T square sine square theta plus T square cos square theta equals to Fe square plus mg whole square. Look, I will take T common. Then we will having here sine square theta plus cos square theta. Then Fe square plus mg whole square. Sine square theta plus cos square theta is 1. So I can write T square into 1 equals to Fe square plus mg whole square. So T is equals to under root of Fe square plus m square. This is the equation by which we will get our net tension in a string, insulated string. Okay. Okay. This case now. So let us suppose we are dealing in space. We have taken this particular thing, the pendulum in space now. So there G is 0. G is 0. So what is T sine theta? Is it Fe? Okay. And what is T cos theta? Is it mg? Divide these two. So what we will get? Sir, we will get tan theta. So tan theta is equals to Fe by mg. Now G is 0. So tan theta is equals to Fe by 0. So tan theta, Fe by 0 is in. So what happens to it now? So look, Fe by 0 is infinite. So value of tan theta is infinite or undefined is when my theta is 90 degree. So it simply indicates if we are going in space, initially my pendulum is like this case, theta and theta. Now if we are taking them into space, this theta will be 90, this will be 90. So my one pendulum will be here, one will be here. So the total angle will be 180 degree. And if the angle is L, this is L. So this will be L, L. So whole length will be 2L. Okay. So my theta is equals to 180 degree. My new force will be equals to how much? Sir, K, Q1, Q2. Both are same charges, no beta? So I will write 2 KQ square divided by 2L square. This is how we can manipulate or we can do these things. We can do these things. Look here. Also, my tension is in this way. My force is in this way. If my tension is more than Fe, it will be loose here, no? Okay, it will be loose. So it will be loose. If my tension is less than Fe, it will break. but neither here it is loosening or the breaking point. So I can write that tension is equal to Fe. So only in this particular case here, we can use tension is equal to Fe. Why? Because the string is not breaking or it is not getting loose. Okay, it is as it is. So these are some cases. Done. Easy. Okay. Now we have to complete today's topic now. It will take some time. Okay. Okay. Now numerical. What we have? Two identical pith balls, each carrying a charge Q, are separated from a common point by two strings of equal length L. Find the mass of each ball if the angle between the string is 2 theta in equilibrium. In equilibrium, right? It simply says that we have some condition like this. We have a condition like this. One pendulum here, two identical, that means Q charge M mass. One here, Q charge M mass. Length equal L. So it is L length, L length. This angle is 2 theta. So if I just break it, this angle is theta and this will be theta. And what I have to find? What is the mass of each ball? What is M? How to get my mass M? Simple. Sir, we know that this here it is time tension T, theta to theta, to T cos theta. This is what? T sin theta, mg Fe, which is kq square divided by. So is there any relation between these here? Now look. If it is R, let us suppose it is R. Now I don't know what is this. It is R. So I can write R square. Okay. Now in equilibrium condition, my T sin theta would be equals to how much? Kq square by R square. And my T cos theta is equals to mg. Look, beta, G is given, M is given, theta is given, but R is not given. Can I take this particular triangle? This is R, this is L. If the whole is R, this will be R by 2, this one will be theta. So what would be tan theta? I can't use tan theta now. I will use sin theta here, okay? Sin theta. P by H, P is L, H is R by 2. So I can write here, sir. So sin theta is L by R2. So I guess I can use the sin theta value here. Okay. Or simply I can write cell L equals to R sin theta by 2. So no, it won't be like this. It will be 2L. Yes. No. I took it wrong now. Look. So what is P? P is equals to R by 2 and this is L. So it would be R is equals to 2L sin theta. Yes, 2L sin theta. So I will write, sir. Okay, I will change the color. So I can write T sin theta is equals to KQ square divided by R. R is equals to 2L sin theta square. Then I have T cos theta, which is equals to mg. Simple. I can use this one. Now let us divide equation first and second. Let us divide these two. So what we have here? Sir, I have two equations now. So it is T sin theta KQ square divided by 2L sin theta whole square. Now divide with T cos theta. So I will divide these things with T cos theta. So T cos theta is equals to mg. Look, T cancel out, just tan. So I will write tan theta is equals to KQ square. I will take mg upwards, so it will become mg 2L sine theta whole square. Then look, I will take M here, this particular side. So my M will be equals to KQ square whole divided by mg 2L sine theta whole square. So I guess this would be my answer. No, why tan theta? No, I took M here, so M is not there. I can write here what? It is G tan theta. Yeah, G tan theta. Yeah. So this is how we can get our value of tan theta. This is how we can get the value of tan theta. Okay. Okay. Now next numerical. Next numerical is like two pitballs is carrying equal charges. Equal charge, that means Q1 is equals to Q2. Both are equals to Q. Okay. Suspended from a common point. Okay. By a string of lengths are also equal. The equilibrium separation between them is R. Now the R is given to us. It is R. Second part. Now the strings are rigidly clamped. That if the strings were okay clamped to half the length. Okay, if firstly it is like this L or something like that, then we just shrink the length. The equilibrium separation between the balls now become. So now we have to follow. Now what we need to do, beta? We need to get our new length. We need to get our new length. This one is good numerical, and it was asked in exam, the NEET one. I guess in 2016 it was asked now. Okay, now how we can get it? Look, it is given to us. We have a pendulum like this from a particular point, one point. Length given to us. It is like this. It will be R by 2. Why? Because the whole length is R. Theta, theta. Because masses are same now. QM, QM. In the first case, if the length is given to be Y, let's suppose it is Y. Suppose it is Y. Now, they're saying that now new condition. New condition. What will be my new condition? New condition will be like this. Look. This would be my new condition. It is R dash. It is Y by 2. No? Clamp to half the length. Y by 2. So I need to find this R dash in the variable of this R. In the variable of this R. How I can get it? Look. That means I have to find a relation which relates R only. So how we can get it? Very simple numerical. Look. Do you know what is tan theta? Yes, sir. Tan theta we know. Tan theta is equals to F divided by mg. Very famous formula. So from this particular figure, this one now, this one. So can I make a figure like this? This one is y, this one is r by 2, this one is theta. So from this figure, what is tan theta? P by B, I guess perpendicular is r by 2, base is y. So is it equals to r by 2y? Yes. In place of this tan theta, I will write r by 2y. It is f. What is f here? F is k q square by r square. Whole distance is r. Now it is r square. Whole divided by mg. Look. G constant, m constant, k constant, q constant. Now this r and y is variable. Now I can write r divided by 2 is constant. Now r by y is equals to 1 by r square. So therefore, y is equals to r cube or proportional. I will take proportional is good term. So y is proportional to r cube. Now here in this second phase, y gets changed, r gets changed. So can I write here r1 cube is proportional to the y1 and r2 cube is proportional to the y2. Okay. So what is r1? Sir, r1 is equals to r only, so r cube. I will take divide. R2 is how much? Sir, r dash cube. Proportional to. Sir, y1 is only 1. Y and y2 is how much? Y by 2. Y cancel out. So I can write r cube divided by r dash cube proportional to the how much? 2 only. Proportional to the 2. It is 2 only, no? Yes. So now I will write r cube is proportional to the 2r dash cube. So r dash cube is proportional to the r cube by 2. So I will take cube root here. So r dash is equals to cube root of r cube by 2. Cancel out. So r dash is equals to proportional to the r by cube root of what? 2. This is my answer. Simple and easy, no? Easy? So I guess my answer is R by, yeah, 2 by 3. Option number third is my correct answer. This is option number third. Okay, now next numerical. Okay. Shall we continue or I need to stop here, no? So I guess we had done one half, no, the 115 minutes class, no? I guess I can stretch it up to 12, no? Then we will stop. Okay? I will just make it up to 12, then we will stop. This one is very good numerical. Okay? This one is a very good numerical, this particular one. Okay, this one. Why? Because here we have to apply some sort of differentiational things. Now the numerical is like that we have two identical charged spheres. But we have two identical charged spheres suspended from a common point by two massless strings. Length is L given to us. Are initially at a distance d. Okay, that means, yeah, these two are separated by distance d, and this d is a very short as compared to the length of the pendulum. Okay, because of the mutual repulsion, no? That's why they are just at a distance d. Now if charge begins to leak from both spheres, now if a body is having, let us suppose, q capital charge, no? There will be a now leakage of the charge, but the leakage of charge, that is dq by dt, is constant. Charge leakage, that means it is changing. My q is changing with respect to time, but it is a constant rate. Now look, constant rate. So I can write here, sir, dq by dt is constant rate. Constant rate. As a result, now the charge is leaking now. That means the magnitude of charges getting lesser and lesser. So if initially my pendulum are like this, now due to the leakage of charge, these will come closer to each other. Now if they are coming closer to each other with velocity v, if these two particles are coming closer to velocity v, so we have to find where is okay, velocity as a function of x. Okay, good one, no? And in a tough category, I will place it in a tough category because this numerical was, I guess, asked in NEET 2016. One of the toughest paper in the NEET history, right? Now in this year you will also face the toughest paper. So we have to just get these things done. Okay. Okay. Now how we can get it now? I don't make any figure right now, or if you want, I can make the figure. Okay, so how I can write it? Look, what is tan theta? Sir, it is Fe by mg. Okay, so look, my pendulum initial case, LL. This is given to be how much? Is it D, no? Yes, sir, D. Okay, initial case, charge QQ, theta and theta. Clear? Now, after some particular time, they are coming closer to each other. Now, this theta is small. Now, this theta is small. We know that if theta is small, so we can use small angle approximation, which states that tan theta is approximately equal to sine theta. We know these things now from where? Basic mathematics. Now, look here. If now they are coming closer to each other at the end, if distance is x, if at the end my distance is x, this one, that means now this one is x by 2, this one is x by 2. So look now, what is now sine theta? P by h, p is x by 2, h is l, h is l. So sine theta came out to be how much? X by 2l, x by 2l. Now, what is tan theta? Sir, it is equals to sine theta now. So I can write tan theta is x by 2l. What is Fe? It is kq square divided by what? X. So I can write it x square whole divided by mg. Okay. So x square divided by 2l is equals to kq square whole divided by x square mg. Look, the length of this is constant. Now it doesn't get changed. A constant. K is constant. Mass is constant. Only the g is constant. No. So I guess x is variable, q is variable. So from this particular figure, what I can write here, I will write here x cube is proportional to the q square. I can write like this, or I can write, q is proportional to the x power 3 by 2. Now differentiations. Can I write dq by dt proportional to the dx power 3 by 2 divided by dt. So look, dq by dt, it is constant. It was constant. So what is the differentiation of, look, this one? So for this one we have rule, differentiation of x to power n is equals to nx n minus 1. So I can write here n is how much? 3 by 2, and x is x, 3 by 2 minus 1, then dx by dt. Constant, constant. This is velocity v. So I can write here constant is proportional to the x power 3 by 2 minus 1. It is 3 by 2 minus 1 equals to 1 by 2. It is 1 by 2, then velocity v. So therefore, I can write v is proportional to 1 divided by x power 1 by 2. This is my relation. V is proportional to the x power 1 by 2. I guess x power 1 by 2. I guess A option is correct. Yes? No, not this one. No, not this one. It is upon. No, if upon, it will become this one. Yeah, this one. Option number this one is correct. This numerical were asked in NEET, in IIT, in Erode also. You will find this thing, right? Okay. Now we have one more numerical. We have 10 minutes left, so we can do, no? We have now 10 minutes left. We can do these things, right? If you want, we can extend the class up to the 1 o'clock or 2 o'clock. There is no issue. I have the full energy mode, right? Okay. Now what we have here, Next numerical is two balls. What we have now? We have two balls of same mass. What we have now? Two balls with same mass carrying equal charges. Carrying what? Equal charges are hung from a fixed support of length L. That means if we have something like that, we have it like this. Okay, length is L. Okay, Q charge M mass. Here what we have? Q charge M mass. Okay, angle is theta, angle is theta. Now we have small angles. Small angle means we have to use tan theta equals to sine theta. Okay, separation x between the balls. Now this separation is x. So I guess this one is equals to how much? X by 2. This one is how much? X by 2. Now we got a triangle like this now. This one is x by 2. This one is L. This is theta. I can use sine theta. P by h. P is how much? X by 2. H is L. So sine theta came out to be x by 2L. 1 second, I need to check something. Someone is just texting me now. 1 second. Okay. Too easy, sir. You made crystal clear, sir. Thank you, beta. Thank you. Thank you. Done? It is half part. No, I have not completed this numerical. Okay. Now, sine theta is given. No, we got this sine theta now. So, yeah, we had to find out which relation x in the L, no, beta? Find the proportional. What we need to calculate at electrostatics, the angle is made very small. Separation angle between the balls is proportional to. Okay, we have to find out the relation between x and L. Okay, so how we can get it now? How we can get it now? So simple now. One formula tan theta is equal to, sir, it is Fe divided by mg. We know it. Okay, tan theta is sine theta by small angle approximation. So it is x by 2L equals to, what is Fe, sir? It will be kq square divided by x square into 1 by mg. K constant, m constant, g constant, 2 constant, q is also constant. So what I can write here, sir, x cube is equals to L. So x becomes L1 by 3. So I guess I can write this L1 by 3, 4, no? Option number 4 is correct. It's proportional here, yeah. 4 is correct. 4 is correct. Okay, now what we can do right now, let's make the numerical somehow harder now. How, sir? Let us do one thing. Let's take this. No, look, we have the pendulum. in a normal condition where G is G. Then in second case, we took this particular pendulum into the space where G effect G is 0. Then we conclude some result is there also now. Now let us put these two pendulums inside the water or inside any liquid. What will happen now? Let us take the whole system of pendulum inside a fluid. What will happen now? Sir, I guess there will be some forces. Yeah, which forces? If this is my point charge, my mg will be downwards. Mg is downwards. But due to the fluid, we have the buoyancy also. Let's make a tougher numerical, no? Because we are preparing for NEET and JE. So we have to make numerical somehow tougher to us, right? One mg downwards. Okay. We know that there will be a Fe, there will be a some condition of tension. Na? Upwards, what we have now? Buoyancy. So first of all, I will just give you some sort of idea now how buoyancy work here. Then we can start the numerical with buoyancy property. Okay. Buoyancy or the upthrust. Look now. If we have some fluid, the dotted thing represents the fluid. This dotted thing represents the fluid. Okay. If here I have particle and the density of particle is sigma. Every time we are taking the density of particle sigma and density of water or anything we are taking at a rho. Particle's mass is m, so I will write, sir, weight is mg. So here what we have, sir, we have a buoyancy Fb. We have a buoyancy Fb. So what is net force? How to write net force now? Net force. Is it mg by Fb? Okay. What is net force? Is it mg effective? Mg minus Fb. What is Fb? Fb is density of water or any liquid into volume into G. Okay. Now what is mass? Look beta. We know that density. Now look, density equals to mass per unit volume. So mass is equals to density into volume. Density of particle is sigma into volume is V. So I can write sigma into V into G minus rho into V into G. What I can write here now, look, can I take sigma Vg common? Then I can write here 1 by rho by sigma. M into G effective. This particular thing represents mg. I can write here mg effective equals to m into g, then 1 minus rho by sigma. Cancel out. I can write g effective is equals to g, 1 minus rho by sigma. So there we got a g effective. Which one? Suryansh, which one beta? क्या बोर्ड्स के लिए एनएफ होगा? Which one? This numerical or my whole lecture series? Which one? So due to the buoyancy, my G changed into G effective. It came to be G1 minus density of water or any liquid divided by the density of your particle. Okay, done? Okay, sir, done. Okay, now let us do some numericals now. Look now, good numerical. Two identical charged spheres. What we have now? Two identical charged spheres are suspended by strings of equal length. The string makes an angle 30 degree with each other. Done. So I guess theta is given to be how much? 30 degree. Done. When suspended in a liquid of density, that means rho is given to be 0.8 gram per centimeter cube. Then the angle remains the same. So my angle is same. My angle remains same inside the fluid also. If density of material of sphere is this much, that means if sigma is equal to 1.6 gram per centimeter cube, the dielectric constant of the liquid, that means we have to find out epsilon r. Look how we can do it. Simple numerical. How we can do my numerical. So we can write it like, look, simple equation that tan theta. So in first case, if we are talking about right here, epsilon r is equals to 1, or I can write G divided by G effective. Okay. G by G effective is how much? G 1 minus rho by sigma. So epsilon r is equals to G cancel out. Look, 1 divided by 1 minus rho is how much? It is 0.8. I get 0.8 now? Divided by 1.6. Ones are, twos are. 1 divided by 2 minus 1 whole divided by 2. It will become how much? 1 divided by 1 by 2, which is equals to 2. So my answer is 4, which is 2 only. Yeah, it is 1.8, beta. Which one is 1.8? Which one is 1.8? No, you have to check your voice now, because in front of me I have also the system now. I'm just seeing the same thing from my phone also, right? But here I'm getting my voice. Okay, done. So now let us do some different profile of numerical also. Let us do different profiles of numericals. And these numericals are like some equilibrium type, right? So we have two charges, but we have now. But if you know now, the both the JE and the NEET level are same, because both are on the same sort of platform right now, right? So if you're preparing for NEET, you are already preparing for JE. If you're preparing for JE, you are already getting prepared for your NEET also. That's why I have made a combined plan in which I am giving you the very uh, common materials, right? So if you are doing this thing, you are able to qualify your NEET as well as your JE. You can do one thing now. After attending the classes, just do your DPPs or do your numericals from your any book for your JE or NEET, na. Then you can come back to my next session. You can just tell me. Okay, do these numericals now. Then you will find like this kind of quality. Now we have next question. Two charges. Each charge equals to Q. Okay, we have two charges equal to Q. Are kept at a x minus 1, x plus 1 on the x axis. Okay. A particular mass. Okay, so basically we have two charges each equal to q are kept at x equals to minus a and x equals to plus a on x-axis. Okay, a particle of mass m and charge q, that is this one particular, this one, it is at this particular position, its origin. Okay, now we displaced it up to this particular height, this is y. So what is net force? Now look, positive repel, so we got F1. Also this positive repel, we will get F2. It's also B. Okay, so F2 will be equals to K Q naught by 2 whole divided by my B square. So look now, if we have two forces acting on a particular one, so I need to resolve it. Okay, look, this will be theta, this will be my also theta. This one would be my F1 cos theta. This would be my F2 cos theta. This would be my how much? Okay, I will write the upwards one. It will be my F1 sin theta. And one more F2 sin theta. You can see here F1 magnitude is equals to F2 magnitude, both equals to F. So therefore I can write here it is F sin theta plus F sin theta, right? It is 2F sin theta. So net upward force is how much? It is 2F sin theta. Here it is F1 cos theta, F2 cos theta. So they will get cancelled out. तो यहाँ पे तो लड़ाई हो रही है. So कुलदीप is hello. Let's just मैं भी आपकी मजे लेता हूँ पहले. कुछ हो रहा है यहाँ पे ना. It's hello. He's just making us fools. Go everyone. Okay. Good. Okay. चलिए पढ़ने पे फोकस करते हैं. चलिए कोई इशू नहीं. So now let's find, now we have to find out the net force, right? So the net force we got it 2F sin theta, but it doesn't match with any other option, na? So we have to find out how the F is related to Y. How we can get it? How we can get it? Look now here. So my F net came out to be, sir, it is only 2F sin theta. Done. So look, 2 is 2. What is F here? Sir, I can write F is K. Q is this one, sir, it is Q. Q2 is this one, it is Q naught by 2. Q naught by 2 whole divided by my B square. Then sine theta. Look, this particular side is A. This is Y. This is B. What is sine theta? What is sine theta? P by H, I think perpendicular is Y and hypotenuse is B. Can I write here Y by B? Yes, sure, we can write it now. We can write it. Look now. 2 is 2, K is K. I can write Q, then Q naught. 2 get cancel out, so there is no need to write this Q now. B square, now look, what is B here? Look, beta. This is A, this is Y. So my B came out to be A square plus Y square root. So I will write here, it is A square plus B square root. Then square multiplied by Y whole divided by B. What is B? B is A square plus Y square root. So this get cancelled out. So my F net came out to be, it would be equals to K, Q naught then Y whole divided by A square plus Y square, then power, it is 1 by 2, that is 3 by 2. Now there is one sentence now that Y is very less than A. What does it mean? So this simply indicates that if y is very small than a, then y square plus a square is approximately a square only. It is what? A square only. So I can write here. Now look, is there anything missing? No, nothing. So I can write here k q naught y whole divided by a square, then 3 by 2. 2 to cancel out. My answer is k q naught y divided by a cube. So from this particular equation, you conclude that my f is proportional to the y only. My f is proportional to the y. That means option first is correct. One second. Okay. So this is how we can manipulate the numericals and we will get our answer, right? So is there any other numericals? Yeah. Okay, one more numerical. So charge q of a mass m revolves around a point charge q due to electrostatic attraction. Show that its period of revolution is given by some sort of equation, right? So if we have something like this, okay, a charge q. So here we have a charge q with mass m. It revolves around a particular charge here q due to electrostatic repulsion. Done. So there will be attraction. Now this is attraction Fe. So there will be a centrifugal force also, right? So can I write here, sir, electrostatic force is balanced by my centripetal force? Yes. So Fe equals to Kq. Then it is capital Q divided by R square. Fc would be equals to m omega square into R. So look now, can I write here KQQ whole divided by R cube equals to m omega square. I will take the m here also, right? Look here, m. What is K? So I can write QQ whole divided by 4 pi epsilon naught, then mr cube. Omega is 2 pi by t. It is 2 pi by t square square square. It is QQ whole divided by 4 pi epsilon naught mr cube. Then 2 to the 4 pi square by t square. Done. So look now what I can write here. Sir, I will write here t square. So t square came out to be 4 for the 16 pi cube. Then epsilon naught m r cube whole divided by q cube. I guess this is my answer. Let us match it now. 16 pi square. Yeah, this is my answer. Okay. Okay, 1 second. Done. Okay, right now. So I guess from this particular numerical, we can do the next class tomorrow. Okay. So for today, thank you very much. Okay, beta. चलिए चलिए. Yes, beta. These numericals are from your IIT and your JE and combined from NEET PYQs, right? So now from this particular slide, we can do in the next class because it is already 12:21. That means we are doing class from previous 2 hours. Okay. Thank you, beta. Thank you very much. So if you have any sort of confusion now, you can just reach out to my Telegram now. I guess you have my phone number also. You can just reach out to me there, right? ओके. अब त्रिजाल बेटा, मैं आपकी वजह से नहीं जा रहा हूँ ना, मेरी क्लास इतनी तक थी, ठीक है? आपसे क्या डरूंगा मैं? डन. थैंक यू.